Okay, so this is the Glacier Analysis Lab. The easiest way to do this is to remove the map off of the back page, flip to the data table in the center here, and work in this particular fashion. The first glacier you're going to look at is the Norris Glacier. You can see the Norris Glacier is right here. Now, there are two lines, one for 1911 and one for 1988. You can see the 1911 is here near Grizzly Bar, and 1988 is further up the glacial valley here. So between these time periods, you can tell that this particular glacier has retreated. So we're going to write retreating in the corresponding spot on the data table. The next thing we need to determine is just how far it has retreated in that time period. So we're going to take the index card I gave you, slide down to the A line, and you're going to want to put a mark on your index card at the beginning and the end of the A line. You'll then be able to slide it down to the scale, and you'll notice that this glacier has retreated about 1.5 kilometers in the intervening time period. So we'll put the 1.5 kilometers on our data table. Now, it's done this in a certain number of years, and to find how many years it has done this in, we just want to find the difference between 1988 and 1911, which happens to be 77 years. The next thing we need to do is we need to calculate our rate. It's simply distance divided by time. Well, we already know our distance is 1.5 kilometers, and our time is going to be 77 years. So we'll take that 1.5, plug it into our calculator, divide it by 77. Now, obviously that's a pretty big number, so we're going to, for simplicity purposes, round that to the nearest hundredth, and I'll put a little note here so that you remember that. Okay? So this rounded to the nearest hundredth. Of course, there's 2, 0, and 100, so we need 2 spots after the decimal point. We see that 9 is above a 5, so we're going to give that 1 a shove, so 0.2 kilometers per year. So now we have our basic data for the Norris Glacier. Part 2 has us investigating where that glacier is going to be in our current time period. For this, our last reading was in 1988, so we know the last reading was in 1988. Now, this lab is set up to be used year after year, so I didn't give you an actual year for the current year, so you need to calculate the difference between 1988 and our current year, which is 2018. So the difference is 30 years. So it's been 30 years since our last reading. We then need to bring our rate down. We calculated the rate above, so essentially you could take this, put it right there. So we have a rate of 0.02 kilometers per year. We then need to predict our current day difference. This is a simple math problem. 30 times 0.02 equals something. It just so happens that I have a calculator here. So we have 30 times 0.02, whoops, messed that up, delete that. So it's going to be 0.6 kilometers. For the last part, we need to plot exactly where this is going to be on our little map. It's kind of our predicted location for our present day. We know that this is retreating, so it means that if it's retreating, we have to predict that the glacier is going to continue to retreat. Retreating is obviously moving back up the glacier valley. If it was advancing, it'd be moving towards the river. So this particular glacier is retreating. So we have to put our predicted line somewhere above the 1988 line. To do this, again, we're going to take our index card. We're going to go down to our scale, and we're going to put a line at 0 and a line at about 0.6, so it's a little bit over half, so right about there. We can then take our index card and line it up on the green line representing 1988. We're predicting that this glacier will move back 0.6 kilometers. So the edge of the glacier we're predicting is going to be there today. We'll then slide it a little ways, put another dot. We'll keep predicting the location of the snout of the glacier today by using our little index card. We can then connect the dots and label it 2018 predicted. And that is about it. You just need to go ahead and do that again for the Takao Glacier and then the hole-in-the-wall glacier here. You'll then need to compare to the image that I gave you on the last page right here of the actual locations to see if your predictions were correct.